Welcome, everyone. It's September 23rd SIG Node meeting. Today we have a bunch of agenda items. Shriram, I put your item right at the top just to, you're just calling out the Wrangler sign up, right?
Yep, that's pretty much it.
Great. Yeah. So if anyone wants to sign up to be a Cup Wrangler for 135, we have the sign up sheet there. We appreciate your help. Moving on to our next item on writable C groups.
Hi, yeah. I don't know if someone would be able to share the cap. I've got some speaker notes here. I'm not sure if I can do both simultaneously. Hi everyone. So my name is Chris, and I don't know if the other CAP co-author, Divya, are you here today? Maybe not. I can probably sync with her offline. Today I'm here to present KEP 5474, which is to propose a new feature to enable writable C groups for unprivileged containers in Kubernetes. I realize we got a packed schedule, so I'll try and fly through the description of what's going on here. So the core of this proposal is to introduce a new field in the container security context called writable C groups. Maybe if you go to the README or the KEP markdown, there's some examples there of what that will look like. So the core of the proposal is to introduce a new field in the security context called writable C groups. And when this is set to true, a container will get access, write access to its own C group subtree. This feature will only be available on nodes that use C group v2 and exclusive to Linux containers. The primary motivation here is to take advantage of the secure delegation model in C group v2, which allows for more granular resource management from within the container without granting insecure privileged access. And there's two main user stories for this feature. The first is managing subprocesses for AI ML workloads like Ray, which is a very common, popular framework for AI ML workloads. These frameworks need to manage the C groups of their child processes to optimize resource usage, and this KEP would provide a first-class way to enable that. The other use case we were thinking of is support for Docker and Docker containers and making it easier to use this for development and testing. Yeah, if you scroll down so you already showed the example of what the security context would look like on the pod. So yeah, this would be a container level setting. In order to make this work, we'd also need to make changes to the CRI API and container runtimes that will be needed to be updated to support it. We also plan on integrating this with the pod security standards feature. The main security risk that we identified with this is the potential for inter-pod resource starvation when pod level limits are not set. So there's no pod level C group setting an upper bound of resource usage. A container could potentially increase its resource limits, which could affect other pods on the node. So to mitigate this, we're proposing that any container that uses writable C groups must be in a pod that has guaranteed QoS class. And this ensures that Kubelet creates a pod level C group that acts as a hard boundary for all the containers in the pod, and it prevents that pod from bursting into the capacity allocated for other pods on the node. Let's see, the Kubelet will validate that the system and container runtime both support this feature, and if they do, then it'll pass this writable C group setting to the runtime via the CRI API, and then the container runtime will be responsible for mounting the C group file system as read-write. And let's see, one last thing to call out is there's, as part of Containerd's new kind of like KEP shepherding process I'm as a Containerd maintainer offering to take care of this work. So I'll be working with Divya on the Containerd support for this. We're initially proposing to introduce this feature in alpha in Kubernetes 135, and then target beta in 136, and hopefully GA in 137. And this would be behind this writable C groups feature gate. So Yeah, my goal, I guess, today is to gather feedback on the proposal, and we're interested on the overall approach, API design, the proposed security mitigations, especially this guaranteed QoS requirement, and if there's any other concerns you might have from a node level perspective.
So if we are we going to allow writing to any field or only specific fields? For example, can I change the kill behavior and somehow that's a security issue?
Yeah, right now it'll be the entire C group mount is writable, so you can
All C
modify
groups.
anything underneath it.
So with that, can I modify how the kill behavior works from a group to maybe specific processes, and is that a concern? Maybe we should evaluate all the fields to see what things I can change so I can interfere with the platform taking actions on me.
Okay.
Yeah, score, that's one, and another one is the CPU side. I'm
Right.
not sure what can CPU side we can modify because
I think it's only a subset of what's
yeah,
visible in the
subside.
parent.
Yeah, exactly. But yeah, so we just need to double check everything. Yeah, make sure it is just inherited. The subset can be modified.
Right.
Yeah,
It also enables. Sorry, go ahead.
No, you go ahead.
Oh no, I was just going to add that it also would unlock swap unlimited. I mean, there are certain settings we discussed earlier and tried to be protective. This would expose the containers to have permissions to modify the resource control in any way they see fit. We probably would need to be.
If swap is enabled on the node, like limited swap specifically, I would guess that the kernel, I think we need to so when we did proc mount type, we basically audited every single mount that was put in and made sure what each of them did. I'm pretty sure swap, if limited swap is enabled and the pod has access to swap, then it should not be able to set unlimited because it should be limited by the kernel to only set a subset of what the parent C group does. But I think we need to double check basically what the pod C group is doing and what the container C group is doing for each of the C group fields that we have, each of the C group controllers we have enabled, and what happens if you try to increase the limit.
Right, but today we are handling only at container level, not at the pod level.
Yeah, so I think it potentially we would have to also set the swap limit on the pod level if we're only setting it on a container. Yeah.
I think by default we should only allow specific fields and mask everything else, right? What do we have the use cases for? Do we have use case for CPU and memory? We just start with that. We do a whitelist approach because that way we can be safe, I guess.
My counter argument is just even score. You can change some of the process score, but it's still things.
Score is not a C group value. Score is set differently.
Yeah, exactly. So even you can change of the sub C group of the score value, but still you are bounded by pod level. So that's why one of the things quality only guarantee of the pod, guarantee of the container is going to have this feature, along such feature, actually constrain the problem. So that's why I don't think about it will be that bad.
Oh, okay. But I guess it'll just be good to still have a table and saying, oh, okay, we verified that this is constrained when set at the pod.
Totally.
You don't want a situation where, oh, okay, now I'm able to do something because there's a kernel.
My point is, I worry about we cannot just mask certain thing, but at least for score, I don't think about the problem. Like damage, right? So the damage and the wellness is limited at the container level, and the worst scenario is limited at the pod level. Right. So and the guarantee pod, I don't think is big deal. So, but then the Alexandra Sosa just mentioned that the device, we need double check of device. Yeah.
So device now works through eBPF with V2. So yeah, but we need to check that as well.
Yeah.
The other thing that I was thinking on this, and I put a note in the CAP, is I'm wondering if it's worth, if we can find a way to make this safe, make sure that all of the C group values are audited and that there's no holes that we can think of. I'm kind of have the feeling that if a pod is guaranteed, then we should just let it have access, just turn this knob on by default rather than having a specific container level not in the pod API, because like I personally believe that C group v2, the way like hierarchy, like I basically trust the hierarchy to behave correctly. We just have to make sure that the kubelet is correctly setting pod level fields where appropriate. But I think we would have to do that anyway. So I'm almost like, do we need a pod level toggle to whether to turn this on? Or if we do this audit and make sure that it's actually safe for any pod, couldn't it be safe for every pod that we make sure it has limits?
The only concern I have it's just trade-off. Do we want to allow all the like guaranteed jobs have this capability, or or we want to even allow some other like the burstable? Because I'm not sure all the use cases can as the guarantee. Of course, we have the in-place pod resizing, make me have more confidence to say, oh, let's just do the guarantee. But still, I want to have some feedback.
Yeah, maybe eventually we can consider doing that, but it's good to have some kind of an opt-in to begin with.
Yeah.
Right?
I was just going to ask the same question. Now that like we have IPPR, workload limit changes are possible from the Kubernetes side, right? Like where are the cases where like, container having full responsibility of all the resources would be preferred? If it is only specific to certain ML use cases like RAIN, would we want to open this for all of Kubernetes? Like it kind of breaks the single responsibility principle. I think that if the limits are changed, how much Kubernetes would have visibility into it? I think we probably would need to think all of that and maybe see if we could address that in the KEP.
Yeah. And then one other thing that I'm thinking of is like there's a notion in C group v2 of a C group namespace, which we could potentially also expose in the pod API rather than have the writable C group knob. And if the container is put into its own C group namespace, then I think you would functionally get this behavior, but in a way that like is better guaranteed safely from the kernel, because it should only be able to affect its own namespace and not like be like anything in the outer namespace. So that's something also to consider, is like whether instead of having this own bespoke like writable C group mode, you just have like another like C group namespace mode. And if you set that to container rather than host, then you get like a writable C group within the container.
Okay. Yeah, thank you. I'll definitely be following up offline with folks here that had comments. And if anyone else wants to leave additional comments on the KEP, really appreciate it.
Great. Thank you, Chris.
Thanks.
All right. Let's move on. Kevin, did we still have this one to go through?
Yeah, it will be really quick.
All right, you're up.
Okay, could you please give me sharing permissions?
Yes. Oh, come on. Oh, you should be co-host. Oh, wait, no, sorry. Wait, wrong person. I'm trying to find your bubble. Sorry. There we go. Okay.
Okay. Yeah, awesome. Well, this is just a follow-up for the previous discussion for pod level resource managers. I just want to keep this simple. The goals for this feature would be to enable hint generation using pod level resources instead of the aggregated container resources. When the scope is set to pod, it will use the pod level resources. And when the scope is set to container, the functionality will continue using and generating hints on a per container basis. And then the second main point is to implement a hybrid allocation logic. So basically, this would allow the user to have containers that are specified and containers that do not specify within the guaranteed pod level resources pod. This would allow to have some containers to allocate specific resources, and the other remainder containers that do not specify, we just receive the shared pool for the total overall pod level resources specifies at pod level. Just one thing that I want to mention is that we will not be changing the Kubernetes quality of service model. It would be still determined the same way for container level and pod level resources. We will not introduce any new policy. Just the current policies will be updated for both pod and container scope to allow for this functionality. We will only continue to allow for guaranteed quality of service pods. No guaranteed pods will still not be allowed for this process. And supporting place pod vertical scaling will not be considered for this KEP because it is still not supported. And well, another important point is the relevant behavior for each scope. This is more specific. I don't want to take more time, but I would like to invite everyone to check this section at the Topology Manager scopes so you can read the specifics of how the behavior would be. And I invite everyone to comment and give any recommendations if you have. I would really appreciate it. Thank you.
Great. Thank you, Kevin. Did anyone have any thoughts on that?
One random thought, like, have we talked with device management work group about the intersection of DRA with all these managers?
There are a lot of discussion related to that one. Like because we need to figure out the DRA CPU driver and also CPU, all those things. So there's the tons of the discussion, back and forth debate. Yeah. This topic, I'm not sure Kevin talked to them.
We did speak with them,
But it's kind of same.
but Praveen is updated on all of this, and Praveen is kind of involved in DRA and topology managed stuff.
Yeah, I mean, Praveen is, I think he's here probably, but he's the one kind of leading the CPU in DRA thing. But we haven't really, like topology manager settings are typically per node, and the goal of DRA is to shift these kind of requirements to the workload author's request, as opposed to like picking the nodes and having that dictate the. I mean, they don't really work together. I mean, that's the short answer, is like they're different means of doing similar things, and we're going to have to reconcile that at some point. But the topology managers, most of them are GA now. Like, they need to be integrated with the new features we're adding. So I think it's appropriate to keep doing it. And we don't know yet. It's still very experimental, the idea of any native resources in DRA. And so that's kind of the summary.
Okay. Yeah. So I think, John, I think there was someone from Red Hat who was thinking about the intersection of these with DRA. So I'm going to encourage him to come to device management and have that conversation.
Yeah. And so actually, Praveen's got a document, and Francesco has been working with Praveen on the CPU driver stuff. So like that document, one of the things he's going to explore is we were talking with Sasha, and he had an idea about another idea around attaching native resources to device allocations. So there's a lot of discussion there. There's a packed agenda here. We probably don't want to go too much into it, but like anybody who wants to discuss it, please talk to Praveen, talk to me, go on Slack, Workgroup Device Management channel. We'll start the discussions.
Sounds good. Thanks.
I
just added a link to the doc where we are kind of exploring like how the DRA would work along with like kubelet based allocation. So in the current model, like at least for the CPU DRA driver, we need to explicitly disable the static CPU policy so that like two things do not compete for like one same like resource, basically like guaranteed CPU allocation. So once we disable the static CPU policy, then DRA driver has control on like what CPUs that it can allocate. But yeah, I think this is an ongoing discussion. I added a link, so it would be good to get your perspective perspective on this doc, and I'll bring this up again in the working group meeting, like probably in the next couple of weeks.
Thanks, Phil.
But I just want to say that there's the longer term haven't finalized, but do we agree we move forward with the current approach? So then we can get more inputs.
Yeah.
I'm talking about the CPU DIA driver. We have the meeting. So maybe, next time, maybe like Proven can update more.
Yeah, that sounds good. There has been like some ongoing discussions on the doc and even on Slack. So yeah, I'll be updating this doc like so.
Good question, at least.
Yeah.
With awareness, because there are so many ongoing things.
Right.
Great. I think then maybe we move on. Alima, you're up.
Yeah, super quick. Thank you so much. I want to give an update on that metric we were talking about. I think it was like 2 meetings ago. Yeah, so there's that correction about init containers running sequentially, like finish running sequentially before main container images start pulling. So thank you for that correction. I implemented, basically I had it where I was counting like the 2 phases of first init container image pulling and then main container image pulling. But now I subtract counting it for each image. So that's like implement correctly where it's like, it was kind of a lot of work, but like it's more accurate for sure. And I fixed that, or I verified that it works with unit tests and manually testing it. So like in terms of that aspect of that PR, that's addressed. We also talked about when we want to start counting the metric. I confirmed we actually want the full end-to-end measurement from pod creation, just as long as we can guarantee that the pod is immediately schedulable. That's also implemented and verified with unit tests and manually testing it. I just would really appreciate just getting if anyone could take a look. I didn't realize that it doesn't have to get added to a milestone if it's a bug fix. So are the next steps, it already has priority. So are the next steps approval or what are the next steps?
It's mostly just review. So we just
Okay, just a review.
on this document and on this PR, and then we can decide whether or not to move forward with it. And then it would be approval, and looks good to me.
Okay, got it.
Yeah.
Okay, and thank you for that conversation in the doc. In terms of who to ping for a review, is there anyone specific?
Yeah, I mean, I can do a first pass.
Okay.
Yeah, I don't have approval rights, but I can take a look. I think another open question that we had last time was like, do we find this SLI and SLO to be like meaningful and useful for us? And I think like I'm pretty sure the answer is yes, but I think we might have a little bit of discussion, just making sure it's worth all of this, tracking and like to track it correctly and make sure that we have that. So that's one thing to consider, but I can definitely take a look at it.
Yeah, I hear you. I mean, it is like basically implemented. So in terms of like what we want, this is something that we want, and it's matching up with the documentation now and with what we want. So I think that conversation should be pretty simple in terms of that. But yeah, I appreciate it. I will definitely ping you. And just to put my name out there, I signed up for the Wrangler sign up. I know that there's a lot of volunteers for that. But yeah, seems exciting.
Yeah.
Thank you for the help with this. That was really it. Just a quick update.
Awesome. Thank you. Yeah, we can continue conversation there on the PR, but thanks for the work there. All right, AJ?
He's on mute. Muted.
Sorry about that. Can I get permissions to share the screen? I just wanted to quickly. Oh, thanks. Okay.
There you go.
Thanks. Only 1%. Okay, I don't know what that means. Let me see if it allows me to share. Looks like someone is already sharing and it is. Can you see the screen? So we already discussed the swap. Can you see the screen? Can someone please confirm?
Yep.
Yes.
Okay. Thank you. So we already discussed this earlier. This is about like a pod level swap control. Let me correct that. Workload swap control for enabling use cases such as fine-grained swap control for containers. Certain containers don't need to have swap. We have like kind of default formula that doesn't work for all the use cases. We also had like multiple users reaching out to the Slack channel asking about unblocking this for use cases. For example, in guaranteed CPU pinning workload, they would still want to have swap guarantees for home protection and use cases like IPPR to be unblocked so that like cost reductions can be handled better. For use cases like this proposal, we already discussed this, like enabled a new swap behavior called workload controlled swap. We got two feedback, one from Sergey and other from Kevin. Just like adding feedbacks here, I just wanted to like bring visibility to this to the folks here to leave more comments if needed. I'll probably send this out to a CAP later today if we have consensus on this or if we have agreement on this direction. Just that wanted to add it here as a plug. I just also wanted to add in that I've been working with a few customers who were using SWAP in a very large setting in Kubernetes and for use cases like to materialize DB views. SWAP is enabling them with good cost benefits and it's allowing them to go for smaller nodes than larger nodes for same performance as needed. So API level small control is preferred for many use cases. Yeah, just adding a discussion for comments. I don't want to hold the time for other discussions if there isn't any feedback online.
AJ, do you want to share your plan with this one? Your plan, like the
yes, I wanted to get the buy-in on the CAP and basically like get the API approvers on this. Once we get SIG Node approval, we would plan this for 1.36 for implementation because the other swap owner who I've been working with, and we also want to get like more time to get feedback coming in. So 1.36 is when it is planned, but I still need API review, so I want to get SIG Node approval first.
Yeah, I was going to ask about the API.
Okay. Yeah.
Good. Yeah.
My point is the reason I ask the plan is just because I personally feel this is relative the lower priority. So we are not rushed to 1.35 and have like the alpha or whatever things. So it's kind of take a longer time to get feedback. But the people disagree, think about want to have this earlier, please raise your concern. But I personally think about in today's production, node swap, roll out and have the production usage and ensure we understand more and use cases and then
we can get some feedback.
Yeah,
from that.
because there are other so many of the feature have relative the higher priority.
Yeah, makes sense.
Yeah, I agree, and I think it would be best not to rush this anyway. So that's good.
Yeah,
that works for me. Great, thank you, AJ. We can follow up on the document and then corresponding CAP when that's open. Praveen?
Can I get like permission to share? I think I already have.
Oh, geez. Yep.
Okay, cool. So I wanted to give like a quick update on the node capabilities kept. Like this was discussed previously for like the 134 cycle, but since then like there has been some refinement in this based on like discussions with SIG scheduling and even SIG architecture, which I wanted to like bring up here. So yeah, like basically just a quick summary, like this node capabilities, or like now after API review, we renamed it to node declared features, is like a mechanism through which like node can report certain features through the node status to the control plane components, like and basically like scheduler or admission controller can make use of this, or even like controllers, external controllers can make use of this to make like better scheduling decisions. So in the earlier version of the skep, like the scope was much broader, like basically anything like kernel runtime or hardware features was like within scope to be declared as like a node declared feature. But after discussions, like in the current scope, like the plan is to make it exclusively targeted towards like handling version skew problems during like newer feature rollouts. So in a mixed cluster environments, like the scheduler and the admission controller knows like during pod scheduling what is available on the node. So basically with this new like scope, every declared feature needs to be tied to a feature gate and would also have like like a well defined scope. Like every time we are during the normal like feature gate cleanup process, like the node declared feature, we can stop reporting that. So on the reporting side, like kubelet remains to be like the only source which can like publish these features. And as I was saying, this is done through the node status, and we have like a list of strings within the status, uh, like using which we can declare the features. And if any external controller like tries to modify it during the regular like periodic node status sync, like it would be reconciled back to the source of truth, which is basically what kubelet determined during the bootstrap stage. So basically kubelet determines a bunch of features during bootstrap and reports them, and only if there is a change it would be reconciled back to what kubelet has. And on the consumption side, the plan is to introduce like a library within the component helpers, and this would be like a single the common place for uh, all the components that want to consume, like scheduler, admission controller can use this single library, and basically use that to infer the requirements from the pod spec, and also pass the node object and like match a requirement from the pod spec to a node declared feature. uh yeah, at a high level, like these are the like basically this is the new scope, and these are the changes that we are trying to like for the 135 cycle. uh uh yeah, open to any feedback on the cap or like here.
Yeah, I like that it's tied to feature gate, so that way we have a way to
Move
keep
forward.
trimming the list.
Yeah, I think that was the main concern. Like basically we wanted to avoid adding a lot of things within the node object, and also have no plan to like deprecate it at a future point. That was one of the main concerns that was brought up by the SIG scheduling review. Yeah, Francesco.
Hey, hello. So I glanced over the last cap update and I have no design objections or concerns, so that part is fine. But I would like to ask about introducing, well, re-expanding the scope later in a future cap after DSJ, everything, but in general, because a kind of a pet peeve of mine is the fact that the scheduler has and the cluster actually has no visibility about the node properties that influence the workload. So the usual suspect, topology manager policy, scope, CPU manager. So exposing that may not fit in this framework, fine, but it really, really, really looks like similar to that. It's very, very similar. So
Yes.
what's the appetite? What's the feeling of the community about extending again future cap in the future after GA, not in this scope, but in general? How do we feel about extending in that direction?
Yeah, like one point there is like currently we don't have a way within the pod spec to also like request for like guaranteed CPU or memory and things like that. So without that, like the concern that was brought up was like, okay, we declare like a static CPU policy, but how do we make that actionable on the control plane? So yeah, that was the main concern. Like unless we can make it actionable,
Okay.
other than like for debugging purposes, is
Okay.
there any other use case where we can actually like make use of this information?
Okay, so okay, my closing thought will be that this is tied to express the requirement on the pod spec somehow. We cannot really split the two concerns. It seems that this is the feedback at the moment.
Yeah, I think that's like for the current scope that is what we are
Okay,
targeting.
okay, I'm fine to me. Thank you very much.
Thank you. Tim?
Yeah, I just wanted to add, I think part of the motivation for narrowing the scope to just these like temporary features is we had the realization that for anything that's like a long-lived feature, for instance, exposing the CPU policy, we feel like in most cases there's a better API for that than just a arbitrary string map. So that's kind of like structured data with well-known possible values. We could, if we want to expose that information, we could figure out an API that has a structured field somewhere rather than just adding it to this kind of grab bag of string key values. Does that make sense?
Okay, yeah, that's everything I had to share, like open to feedback on the cap as well.
Great. Thank you, Paveen. Next up, we have, is it Nico?
Yes, hello. I'm Nicolas. Nice to meet you. It's my first time joining such meeting.
Welcome.
So let me share my screen. Okay, I think you can see my screen. So today I'm gonna present you this KEP 5497. It's an idea me and some of my friends had about Kubernetes. I discussed it a little bit with the issue, the pull request comments with a lot of people. And initially, the idea was to add a new image pull policy. And that would be something like if digest changed or if you were not present. That was the concept. So that we pull an image only if the digest ID on the remote is changed. Yeah. And that idea came because sometimes we use tags like latest, or we may have a hot patch and go back to a version, for example, 1.0.0 and patch it live in case of significant, for example, bugs that may occur. And the thing is that we have right now the always that can do this job, yes, but always when you restart the pod, it will try to connect to the registry and pull the image and rerun the pod, yes, the container. But with this idea we have here is that we won't say pull the image, we will say give me the digest, get the digest and compare it to what we have resolved from the image right now, from the local image. So it is like this concept of having the always and the if not present somewhere in the middle. Yeah. So we want the abilities of if not present and the abilities of always together. So when you, for example, use this if digest changed, let's say, mode, then we pull the image if the digest changed, or not pull the image and use the local one if it exists, of course. If it doesn't exist, then we pull like we do with if not present. And the difference with the always is that always will try to pull the registry even if the registry fails. For example, even if the registry has a huge latency, yeah, and that it will try to compare the image layers and it will try to pull if they are changed. And with this mode, I suppose we won't pull this, but we will pull only the ID of the image, compare it, and then use the local if it exists. If not, of course, we have to pull like we'll do with always. And in case of failures of registry, for example, and you cannot pull, then you fall back to the local image and you keep using the image you have. That's the whole idea. I've had a lot of comments in the issues. Some people disagree with me. We should not be using the same image version and we should not be using things like that. But imagine you are using staging. Yeah, it's a name. You cannot have staging 1, staging 2, staging 3, or you cannot have, for example, demo or other tags that are static. Yeah? And yeah, it is anti-policy, anti-good strategy, yeah, to go back and patch an image, for example, version 1.1.1, but it may happen. Yeah, you may release something accidentally and you need to fix it fast and prevent people from pulling this bug. Yeah, so that's the idea behind it. Some recommendations I got from Mike Brown, actually, from the channel on Slack and issue, is that we should not maybe create another image pool policy, but pass some kind of annotation or some kind of spec value to the CRI, and the CRI should decide what to do after with the image. For example, if it cannot pull the image and it doesn't find the local, then to fall back to the local existing, yeah, or image pull back off if it doesn't exist, or in case of always pull, yeah. So we can pass from spec some new variable that will define the pull fallback policy, let's say. That's all, I think, from my side. I don't know if you have any comments. I'm happy to hear it. And if someone wants even to assist on this KP, if it gets approved eventually, happy to receive any help.
Thank you, Nicholas, for this work. Yeah, I agree with Mike. I mean, I generally think that this kind of stuff should be up to the CRI. The behavior semantically is very similar to pull policy always. Like the CRI should be smart enough to know that if there are the actual bits of the image local on the node, like if the digest was already pulled down for that specific layer, it won't like re-pull it. Like it shouldn't be doing that. So like semantically, what is the difference between this, if not newer than like always? Because some entity, either the kubelet or the CRI, has to check that the digest changed, and that is always happening with a pull. But then if the digest has not changed, in the always case, we're not re-pulling those layers. We shouldn't be, at least. And if it has changed, then the image pull policy means that always means that we pull it down. So it seems like we get this behavior with image pull policy always.
Yes, exactly.
Yeah, I agree.
What we discussed with Mike Brown, yeah, this is happening, and
actually.
Exactly. If
it
it's
is very validating the layers, yes. And the difference, let's say, with this is the middle part of if not present and always. It is that it will fall back to the local image in case it has problems to pull the image from the registry. So this is the biggest point of this. And it's, for example, when you don't want in production to use always. You don't want in critical systems to use always. Something happens and restart a pod, you don't want to pull a new image sometimes.
Yeah, I mean, in that case, I would honestly think that should be a CRI configuration. I don't necessarily think the kubelet should be responsible for telling the CRI that. I mean, it all could be configured within the CRI, so I'm like, why would the kubelet be aware of it? I think the kubelet could just have image pull policy always, and then the CRI could like be told whether to fall back to the local image if appropriate. AJ, do you have a point?
Yeah, I was just going to add that the standard or the best practice is to use immutable tags. The kubelet going ahead and supporting like against that doesn't seem like a good idea. Like the alternative, I think that if someone really want this is like create an admission controller or something so that this is intercepted and translated into current digest at the control plane level. So each kubelet doesn't need to resolve this for each pod pull request, right? I mean, if latest to recent or image freshness is really needed, they can still achieve this at the admission controller level. Kubelet doesn't need to be doing this, in my opinion. It just like goes against kubelet supporting something that is considered widely as a bad practice, I thought.
What about passing this policy as in the beginning I discussed with Mike Brown, like passing it from kubelet with an annotation down to the CRI and and then the kubelet will instruct the CRI what to do. Yes, kinda.
Yeah, I don't think I think the CRI should be responsible for this. I don't think the kubelet should tell the CRI to do anything. Like I think that sort of muddies the responsibility between the two. Like the CRI is ultimately the entity that is deciding what image to pull or when. Like the kubelet is going to ask it to, and it, but so I think if anything, this should be a field in the CRI, and we can sort of debate on what it looks like. But like, I don't think the kubelet needs to be aware of it personally.
And also, I think it's safe to change that always semantic based on the digest. When we first define those kind of things, actually the digest is not available. So that's why we don't compile off the digest. Do you remember that one? That time we only rely on the image and then the version number, and to say so that. But the problem is we cannot trust those version number,
right?
Because they can change the tag because it's just tag. So that's why we always define tag real always, even like the data already available, but when the data is available, we never change those. So make that is really suboptimal. We can change that to semantic. It's just bug to me.
Yeah, exactly. If it's latest and if that digest is already there, the CRI, I mean, the runtime should detect that and immediately return that. Okay, I'm going to do anything. Yes.
And I think I spent too much time reading this cap all over again. I think the point here is if you by always you say if you're not sure, don't just fail on me. And we propose to change the semantics that if you're not sure whether it's latest or not, then always will return something, and you have no idea what it is. It may be like from last snapshot, like image was snapshotted like a few days ago, and it says very stale image there.
But you still need to trust the digest, right?
But with latest, you don't know, right? Because you just have the digest. You don't know which version.
I'm not advocating for this cap, by the way. So
no, I'm trying to figure out if we have a gap we need to close based on what you said.
So I really feel like if you'll do change on CRI level, saying always now means that try to pull always, and if you don't see this image on a remote because it failed or give you 404, go to local. That seems like a security problem for me.
The problem is, this is the problem. Earlier I said why we define always. It's just in the past, in the OCI, all those kind of things, and the image, container image, they don't have the digest. They don't support the digest. So, and the only we are differentiate that is the tag associate, like the version number or latest. And we cannot trust that. So that's why I introduce always, because we just don't know. Yeah. And so then later they did have the digest. We started using digest, but the semantic for the always is still changed. What they ask, actually, basically it is just, I want you give me the latest whatever you want, right? So then always, if it's the digest of the change, and I believe there's the updates, then it's pull latest one.
No, the difference is today always, like, imagine a situation when remote deleted the image. So today always will fail to give you this image because it doesn't see this image any longer, even though there is local bits for this image for previous digest.
That part, that's the second part of
Yeah. Okay, okay, there was a security issue, so I pulled that from the registry.
Completely. Like, I don't want anybody to use it.
Yeah. And now you start using it because it's present locally. Yeah, that's a good point.
But that behavior can still be persist even with digest. So, the way I view digest is essentially like an E tag that we use to save network bandwidth. But if the remote is missing the image is
the semantic. Second part of the semantic we didn't cover from the always and if not present.
But wait, Sergey, we don't know whether the registry is down or whether there's a security issue.
Yeah.
Exactly.
That's why it's really hard to tell.
Also, there is a use case. For example, you have a diamond set, yes, and you have this latest image. You roll it out, and you start pulling somewhere. But some nodes, for example, fail to pull from registry, yes, and then you have a new latest or a new staging image that comes with the always, and still you have half of the nodes running the staging version 1. And the staging version 2, because as you say, we use the tag now, yes, and you don't know if the tag will pull the latest digest or it will pull the previous one. So this is happening with always.
Yeah, but I think that's why like pulling by tag is like semantically confusing, and I think it's like instead of introducing a new option that would like I think even adding the new option would sort of continue to confuse the matter, because it's not like the daemon set pods that started like in the first set would get restarted. It's not like we're going to be re-rolling out all of the pods automatically with this feature. All it would mean is that like there is an additional step in the image pulling process where the kubelet checks that the image did update, but we get that with always anyway. So if a user wants like to make sure that like their daemon sets are consistent between versions, they should specify by digest. And then if they want it to update, if the digest updates, they should do a new rollout of the daemon set and have new pods be created for all of the nodes, not just like the ones that didn't happen to be. So like you can get these semantics by using digests, and it's the idiomatic way to do images generally. So I don't personally, I'm still not convinced that we need this new image pull policy, because like that would be basically patching on top of like tags, which we're sort of saying are like not really the best way to do things for these reasons.
Okay.
Yeah, I agree with
What
Peter.
about correlating the image pull policy with what is passed on the CRI? For example, when we set if not present to pass this if not present to the CRI.
You just pass the, like basically what the kubelet does is it is checking whether it's like constantly asking the CRI what images exist on the node, and it's comparing that against what's being asked by the pod spec. And so it basically asks the CRI, okay, do you have this image? And if not, then it says, okay, please pull this image. But it's not telling the CRI use this image pull policy for this pod. It's like doing it sequentially step by step. There's a side conversation talking that we've been having for years about whether we should make that more declarative rather than imperative. But we're not going there for now. So basically, like, yeah, if the image is not present, the kubelet will detect that and ask the CRI, can you pull this image? If it sees that the digest is present, then it will not do that unless image pull always, and then it'll ask the CRI, can you try to pull this image? And the CRI will check if the digest has changed. If it has, it'll pull the new bits. If it has not, then it won't.
Exactly. The problem there, that was the second use case, yes, because it was two use cases. One is to pull and check the digest, and the second use case was the fail over or the fallback.
Right,
yes.
and I think
When
the
we have
failover piece should be done by the CRI. I don't think it should be the kubelet.
Okay.
An image field is mutable, so this is your escape hatch. You can always, like, if you want to do tags instead of tags, just do with digest and then iterate over all the containers and update image on them. It's a mutable field, so it will have almost the same effect if you trying to achieve.
Okay, thank you. I don't know, do we cancel this KP? Do we close it? Since
Yeah.
I believe that we totally disagree with this, yes.
Peter, can you summarize?
Yeah, I can respond on the CAP.
Yeah. Then we can close. Yeah. Thanks.
Thank you very much.
Thank you for joining. We are at time for today. As an announcement, we have to get started on KEP planning because our KEP freeze is in now 3 weeks, but from next week, 2 weeks. So yeah, I'll be going through the board and organizing everything. But if you want something to be worked on in 135, please reach out to one of the leads. You can ask me or Sergey or anyone to add it to the milestone so we can be tracking it. And other than that, thank you everyone for joining. Talk to you next week.
Thank you.
Thank you.